All right, everybody, welcome to the Humans to Mars Summit once again. It's wonderful to see you here today. My name is Ron Sparkman. I'm the communications and the social media director here for Explore Mars. And because of some things that have happened, Elon's on the call with us right now, but he had to call in because he had to go to Germany. So we're glad to have you here today. I don't think that there's really much of an introduction that's needed. So let's welcome Elon Musk, Chief Engineer of SpaceX, to the summit. Elon, how's it going today?
Good. Yeah, things great. Exciting times. We had a good launch yesterday. Yeah, things are looking promising.
Well, we're excited to talk to you today, and we're going to kick off with a great question. This comes from 4-year-old Esther, and she wants to know, why is it so important to settle Mars?
Well, I think there's two main reasons. One is defensive, in that we want to make sure that civilization continues, and even if there's something terrible that happens on Earth, either made by humans or natural, so we want to have like life insurance for life as a whole. So like life, you buy life insurance not because you think you're going to die, or can hopefully not, but because you might. And this is like life insurance for life as a whole. And we're life's agents, so we got to, the other animals can't get to Mars, but we can bring them there. So I think it's important for the preservation of life as we know it, to be a multi-planet species and ultimately an interstellar species. And that's kind of the defensive reason. And then there's the kind of excitement and adventure reason, which is, it's a much more exciting future, where we're out there among the stars and exploring the galaxy and finding out more about the nature of the universe and how it got here and our place in it, and maybe there's some aliens out there. Who knows? So I think it's supposed to be an incredibly exciting adventure, and then it's important to ensure the long-term preservation of life and consciousness as we know it.
And so with SpaceX is successfully flying Bob and Doug Hurley to the ISS, routine operational astronaut missions set to begin as early as October, and 90+ orbital launches flown, including 3 with Falcon Heavy. Where's your confidence level in getting humans to Mars, and have these programs helped you to design your deep space spacecraft?
I think given enough time, SpaceX will get to Mars. The question is, how long is it going to take us? And then getting to Mars, I think, it's not the fundamental issue. Fundamental issue is building a base, building a city on Mars that is self-sustaining, such that if the ships from Earth ever stop coming, that the Mars city doesn't die out. That's the real tough threshold. If you think about, we went to the moon, but it was like 50 years ago almost, that last time we went. And we haven't been back since, almost half a century. And that's good as far as the inspiring humanity and stuff. But it's not. We can't have that be the case for Mars. We got to go, and we got to build a propellant plant and initial Mars base and Mars base Alpha, and then we got to build a city and get it to the point where it's self-sustaining. And I'd want to emphasize this is a very hard and dangerous and difficult thing, not for the faint of heart. So good chance you'll die, and it's going to be tough going, and but it'll be pretty glorious if it works out. So kind of like what Shackleton said about going to the South Pole. So certainly the programs we've done thus far have been informative of that ultimate objective, but they're really very small. They're very sort of small scale compared to what is needed for making life multiplanetary.
And I think you're pretty famous for a quote of, "I want to die on Mars, just not on impact." So I think that's kind of where we're all at. So let's talk. Oh, go ahead. So
Sorry,
we're going to talk a little bit about Starship. 6 Raptor engines on
Sure.
Starship, 31 on Super Heavy. I mean, there's just so much that we're going to see in the future. So let's talk a little bit about Starship. Everybody's excited about it. I know that we've got a big update coming up, possibly in October. So we definitely want to talk a little bit about what's going on with Starship. We've been watching the hops, and they're very exciting. So anything in particular that you're just over the moon excited about right now with Starship?
Over the moon.
Tongue in cheek. Sorry.
Well, we're making good progress. The thing that we really need to make progress on with Starship is the production system. So making a prototype of something is, I think, relatively easy. Like in my view, the idea of something is very, frankly, the very easy part, and then a prototype is like the sort of initial manifestation of that idea, also relatively easy. But building the production system so we can build ultimately hundreds or thousands of Starships, that's the hard part. But we're making good progress on that production system, as people can see from like the aerial photos of Boca Chica. That a year ago there's almost nothing there, and now we've got quite a lot of production capability. So we're rapidly making more and more ships, and we'll be starting on the booster soon. In fact, we'll be starting construction of the booster this week, of booster prototype 1. So that's going to be pretty cool. So it's really scaling up the production system would be the actual hard part, and we're making good progress on that. So that's what I'm most excited about. By the way, we'll probably have we might have fewer than 31 engines on the booster because we're trying to simplify the configuration. So it might be 28 engines, which is still a lot of engines, obviously. We'll also end up cranking up the thrust on the engines. I think probably long term the outer row of engines, the 20 engines that are purely for thrust but don't gimbal, they don't steer. I think those probably end up like well over 250 ton thrust, maybe 300.
Well. So you've also talked about the orbital refueling, and it's we've all watched that video a million times of it, and it's an incredible thing. So why is that such an important piece of Starship that we need to do that from orbit?
Yeah, if you want to get to Mars, you got to do the orbital refilling. And most of what you're doing is putting oxygen up there, because the propellant is about 78% oxygen, 22% fuel. But it's kind of like if you want to get long range on an aircraft, like super long range, you do aerial refueling. Well, it's kind of like that, but in orbit. And so you can basically put the ship in orbit with say 100 to 150 tons of cargo, but the propellant tanks are essentially empty by the time it gets to orbit. And then you send it up, and you fill up the tanks with dedicated tanker missions. And then that means you can depart from Earth orbit with fully loaded tanks. Depending on how far you're going, you could you have a lot of delta V to get places. And currently, the tanks will do about 1,200 tons, but we could obviously stretch that and make it 2,000 tons if needed. So you can really go far with that ship. I think we can get the non-cargo portion of the ship mass well under 100 tons over time, and then let's say you got something on the order of 100 tons of cargo. And if you want to go far, you'd put less cargo on, obviously. Like if you want to go really far, you just go maybe have like an 80 ton ship and 40 tons of cargo or something like that. And then stretch the tanks maybe 2,000 tons per pound. And then you easily go to the surface of Mars and surface of the Moon and back, no problem, without having to have a propellant deeper on the Moon. You know,
So, when do you expect the first orbital flight to LEO and re-entry of Starship? Will we be seeing that in the near future?
probably next year. But I hope we do a lot of flights. Yeah, the first ones might not work. You know, this is uncharted territory. Nobody's ever made a fully reusable orbital rocket. So, yeah, just having that at all is pretty significant. And then having something that's twice the size of a Saturn V, that's also fully reusable, and has better total sort of delta V efficiency when factoring in mass ratio and ISP. That's really something else. That's profound. That's the gateway to the galaxy. Well, at least the solar system.
And I mean, who's not excited about that? You know, one of my favorites is the original video where, you know, I'm excited about Mars, but you know, going beyond that, even for me, is exciting. I always say I want to go fishing someday on Europa, and I love that that video where it's landed there and you see Jupiter in front of you, and I think that's kind of the intriguing thing about it. We all want to get out there and we want to see more. Mars is the next logical step for us, and we're all excited about it. But that's pretty cool too.
Yeah.
Yeah, so you've stated that you will fly a cargo version of Starship to Mars in 2022 to be followed by a crew flight in 2024. Recently, you also won one of the NASA Human Landing System awards with Starship, which aims at landing humans on the moon in 2024. Does this big wing change your plans for Mars, and how do you see the lunar missions helping to prepare for Mars?
Well, I mean, you know, it's definitely the NASA support is appreciated, but I mean, this is like a program that's like, you know, over probably more than $5 billion. So I think our NASA contract so far is for I don't know, 100 million or something like that. There's maybe 150. It's like 2 or 3%. It's helpful, but it's not game changer. But hopefully what we can do is you know, if we can demonstrate success with Starship, then NASA can start thinking seriously about a lunar base, you know, moon base alpha, and you know, but in order to have a real base, you need serious cargo. You know, serious cargo down, and you don't need to have as much cargo back because, you know, what you'd be taking back is just kind of people and, you know, some moon rock samples. But for mass down to the surface of the moon, you need a lot of that. You know, hundreds of tons, maybe thousands of tons. So, you know, Starship can, it's the only thing that can do that or could do that. I mean, that I'm aware of, yeah.
So, so from this one comes from the SpaceX Reddit group, and they want to know how much of the long transit crew habitat and life support R&D is complete percentage-wise for Starship.
Well, not much, because we got to first make the thing work and automatically, you know, delivering satellites, you know, do hundreds of missions, I think, with satellites before we put people on board. But obviously, we know how to make a complex life support system that can deal with a wide range of environments. Changing atmospheric pressure, changing the oxygen and nitrogen percentage in the air, and obviously we've made spacesuits that are capable of taking total vacuum depressurization. So, and in terms of like filtering out CO2 and other stuff that people breathe, like farts and stuff. We know how to do that. For a longer mission, like if you're going to Mars, you'll want to have a more renewable system than what we already have in Crew Dragon. You'd want to recycle things, recycle water a lot more and oxygen a lot more. But if we're going to the moon, no problem.
And I had myself muted there. So if and when SpaceX were able to land humans on Mars, what would you hope the headline would be that would come back to Earth?
I haven't thought about that at all. I don't know. Humanity's on Mars.
Humans, hey, we're okay with that. Humans are on Mars.
It's going to be something like that, you know?
That's excellent. I mean, excellent answer. I mean, we're happy with that. So, hey, humanity is on Mars. We finally made it. So, obviously we've got some questions here that are coming in, and one of the things that everybody is really excited about, the Raptor engines and what you're producing with those. There's so much that this hinges on. So when we talk about that and what Super Heavy is going to look like and what we have that's happening out there right now, the Raptors are a big piece of that. So can you talk to us a little bit about that in detail for those that are watching, because there's a lot of people that are asking.
So talk about the Raptors in detail.
Yes, please, sir.
Okay, sure. Well, let's see. The Raptors are, liquid methane. It's methane oxygen. So propellants are subcooled methane, liquid cooled. But below their liquid point temperature, oxygen and methane. It's roughly 3.5 to 3.6 to 1. Oxygen to fuel ratio. In fact, when we took Raptor to a chamber pressure of 330 bar recently, we got almost 1100 bar upstream. So that was pretty intense. I think about 1070 maybe, but just under 1100 bar, which is pretty bonkers. A bar is 1 atmosphere. So the rocket equation is very simple at the end of the day. It's like, it's basically the effective exhaust velocity times the log of the start to end mass ratio. So, which really just means how fast are you shooting gas out the end, and what percentage of your rocket is propellant. From a physics standpoint, a gas staged combustion, full flow engine is the architecture with the highest potential capability. So if this was like gymnastics, like what's the hardest trick you can do? Like you get graded on like how well you do within the difficulty of your trick type of thing. So this is like definitely the A+ architecture, and then as we gradually improve it, we then kind of like we'll get a grade within that architecture, and we're progressing pretty well. I could see it, but like it's not actually out of the question that we could get, for example, a thrust to weight of 200 in the thrust optimized version of Raptor, which would be even more than Merlin, which currently has the record for thrust to weight of an engine. So the thrust weight of 200 would mean that the engine can lift 200 times its own weight, which I think is within the realm of possibility. And then for vacuum efficiency, you want big nozzles. That's what we want to try to get to over time. A 380 second ISP, maybe a little better, which can be done with methane and a high combustion efficiency, high pressure methane engine with a big nozzle. Is there anything else to know about it? I could go on for quite a while.
Oh, no, I was going to say, I asked Elon if you would go into depth. I mean, you didn't even get started. I mean, I know there's so much more to talk about, but no, that was an incredible breakdown. And I know everybody that's listening, I'm sure just picked up a lot. So we're going to just do one more question. And this one is, what do you think is the biggest challenge of 1 million people on Mars?
It's just what matters is getting the cost per ton to the surface of Mars as low as possible. It needs to be low enough to the point where some combination of individuals and governments can afford to send that level of tonnage to the surface of Mars. So you've got, like I say, a Venn diagram of desire to go to Mars or send stuff to Mars, and then the other circle of the Venn diagram is like how much does it cost? You know, like basically the affordability of it. And when the affordability, intersection of sets of affordability and desire gets to, let's say, 1 million people, then that's when you get critical mass and you have your multi-planet civilization. So we got to try to get, I don't know, 1 million tons to the surface of Mars as soon as possible, before we do something dumb to ourselves, or there's like a big meteor or some super volcano or who knows what. I don't know, maybe one day in the future, Mars might rescue Earth. That's certainly possible.
I mean, I think that would be pretty wonderful, wouldn't it? So to put all this together and to be like, that's going to be such a big moment for all of us. Obviously, this is the Humans to Mars Summit, and it's what we're going to be talking about all week. And we can't thank you enough. I know that this has been kind of back and forth, and especially to be on the road and have to call in and still making the time for us. We can't thank you enough for coming on and just dive into some of these amazing details. And me personally, I can't wait to buy a ticket. I definitely want to be on Mars. Don't want to die on impact, but I wouldn't mind dying there. So,
Whoa, I mean, that's great. I mean, I think the part of the reason I want to do this is like we need a lot of people fired up to go to Mars and want to make it happen, and then it's going to be kind of risky, but kind of a cool, fun adventure. And so I think people like you and the others at the conference are very important to making this happen.
Well, and I want to be the first DJ on Mars, man. So if I can, I'll DJ the first party whenever we get there, if that sounds good to you.
Sure. That sounds good.
Awesome. All right, Elon, thank you so much for coming on and joining us today. And we'll hopefully see you at the future on at the live event if we can.
Okay.
All right. Thank you so much.
Good.
And thank you, everybody, for joining. Our next panel will be this evening at 7 p.m. MDT.